This is TWIS. This Week in Science, episode number 1008, recorded on Wednesday, March 26th, 2025. Where's the group chat for science? Hey everyone, I'm Dr. Kiki, and if you have a science group chat, make sure to add me if you've got my phone number. But today we will add to your head planet power, lots of lithium, and sharks. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. Science feels like it's under attack lately. And it is. It's happening. But it's not alone. The current executive branch of the United States government has decided that the American people are fraudsters. Yeah. Anything spent on the American people is a waste of time and money. They have determined that the resources Americans have pooled together through taxes and invested in ourselves is a form of theft. From who? Policies supported by the people, paid for by the people, in order to keep us people healthy, educated, secure. Generational commitments between citizens, each giving a little for a greater good, for infrastructure, parks, clean water, clean air, untainted food, and defense of basic human rights. We all pitch in to keep small farms working, teachers teaching, the elderly housed. We pitch in to provide for ourselves, our neighbors, our communities, and our nation. A pooling of resources that has put American science ahead of the world in medicine, technology, military, and now, almost overnight, America has been deemed a fraud. And most insultingly of all, it has been deemed a fraud by individuals who have not been pitching in their fair share, but are now looking to redistribute the people's collective efforts however they see fit. The executive branch has not cut waste or fraud, has not been returning lost revenue to the national investments or back to the people. They are in the process of doing just the opposite, delivering the collective investments of a nation towards private schemes. Science may be under attack, but so is everything else that makes America great. That is everything except for This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you, Kiki.
And a good science to you too, Justin, and everyone out there. Blair is out sick again tonight. We do hope that she will be well very soon. May the coughing no longer commence.
Weakling.
No, there's some serious
Get an immune
viruses out
system.
there.
Fight back.
Oh,
Come on.
I mean, she has an immune system. This is part of it. Anyway, this is This Week in Science. We're here to talk about all the science that we liked to talk about this last week, and we want to talk about it with you. So we're going to talk about it with each other and with you. So I do hope that you enjoy the show ahead. Oh, this week's show. What did I bring? I brought stories about pig livers, planet power, cells full of glucose, memories, and shark sounds. What'd you bring?
I've got narrow-minded algorithms, how the World Wide Web is making everyone's universe very, very small. I brought a story about I got to figure it out. I got to read the thing still. It's something that looks like there's a meme coin that has been put in charge of deciding the funding of science. So we'll
Like
figure out what that's all about.
flipping a meme coin? Yeah, okay, I need to know more about this.
Some kind of failed meme coin, I think, got put in charge of things. I'm not really sure.
Oh, no.
We'll figure it out. What else do I got? Oh, environmental impact of lithium mining may be underestimated. Something that needs to get looked at. And then I've got one more story. Oh, and then this is an interesting one. It's too bad Blair's not here because it's something that I think has come up before. But there's a specific case study that they've done that shows that bottlenecking of genes in animal populations don't necessarily correlate with population collapse. That there's a lag, like a really big one.
Yeah, I can imagine that.
And so it's one of the tools that they use to determine whether or not there needs to be a conservation intervention. But based on the study that we're going to talk about, that might not be the best way to do it.
Well, it's good that we're finding things out. That's what science is for. Let's figure out the best way to do it. Okay, how does it work? How does this show work? Well, right now, I tell you before we go into the sciencey stuff that this is This Week in Science. And if you are not yet subscribed to this program, please head over to twis.org. You will find links to places to subscribe. You can also find us on YouTube, Facebook, and Twitch, live streaming Wednesdays, 8 p.m. Pacific time-ish. And additionally, we are on most of, if not all, I'm not exactly sure anymore, the podcast directories that are out there. Just look for This Week in Science. We are also TWIS or TWIS Science. You can look for these various things on social media as well. Twis.org is our website. That's where our Patreon and our Zazzle links are as well.
And thanks to the Patreon, we don't have any kind of federal funding. So our funding can't be cut by anyone but you.
It's all you. You support This Week in Science. Yeah. We are not federally funded, so we can say things. We may never be able to talk to federally funded researchers ever again. But
like that wasn't on my list of things to do anyway. So it's all right.
We'll see. All right. You ready for the science? Should we dive in?
Yeah.
Okay, my first story tonight. Let's talk about pig livers. Like a good pig liver pate? What about... No, nobody wants that. What about...
It's a mainstay at breakfast in Denmark.
Oh, okay. Yeah. Well, I'm not a fan. I'm going to say is mainly being veggie. I'm not reaching for the pig liver pate in the mornings for breakfast. Not going to do that. I might, reach for, I don't know, the Jetost and the Oosterhovel, but I don't know. I can't pronounce these things correctly. Let's not talk about Danish cheese and cheese slicers. Let's talk about pig liver transplantation. So big story out this week, researchers publishing in Nature their successful test of a gene-edited pig liver that was transplanted into a brain-dead human being who was kept alive on life support for 10 days. They gene-edited the pig and the liver for certain markers that are involved in the autoimmune response to try and reduce the autoimmune response that comes from other animals' organs being put into your body. Your body doesn't like a sliver, so your body's not going to like a liver, right?
No.
Push it out, push it way out. What they found is that it was really successful. There were no signs of inflammation in the body of the person who received this transplant. There were no signs of rejection. It was a short-lived test, only 10 days, but the body continued to work. The liver continued to work. There did not seem to be a buildup of anything that would be indicative of the liver not working. However...
Wait. But
yes.
How did they do that?
What do you mean, how?
Yeah. How?
How? Well, they took a liver out of a pig.
Yeah. I know. I get that part, but they didn't do. They. I mean, they weren't supplying the human body with all sorts of anti-rejection drugs or
They were
some new.
testing to see how well it worked and how much rejection
Just
there was, because they didn't want
okay.
to. They didn't want to disable the function of the liver, because one of the functions of the liver is to detoxify the body. So the liver is actually much more complex than other previous porcine transplants. And so there was a successful porcine kidney transplant that we reported on a while back. A woman who was elderly back in November had had a kidney transplant and was working very, very well. In this case, this is early stages. This is not even a full transplantation. They just wanted to see if the body would take it and not reject it too much, and if it would continue to work and support the life functions of that body. And so it was like an auxiliary liver. They basically added a liver, a pig liver, to this person's body to see if it would work. And it did. They're very, very optimistic about the results. They say that the antibodies were working very well. They were able to surveil the situation, and everything was great.
It just
So
tells you how highly the body prioritizes the liver. You put a pig heart in there and be like, oh, it's the wrong flavor of heart. Get it out of here. Reject. But the liver, it's like, yeah, but it's a liver. I mean, who doesn't need one of those?
yeah, and hearts they've done already. Pig hearts have been transplanted, and they've also done an external pig liver to a brain dead person with liver failure. So it was outside the body, and then they pumped blood and they threw the liver and then returned the blood supply back to the body. So kind of like an external filter.
Because the body even rejects stem cells that aren't from the right.
Yes.
Like, that's pretty impressive that we can just take on a pig liver.
Yeah. Let's see. So, what they genetically modified, there were 6 genes that were edited in this pig liver.
Aha. Okay.
That's what I said. It was gene edited.
Yeah.
So it's not just a pig liver. This is
okay.
It's modified.
I missed the gene edited thing.
Oh, okay. I thought I said that a couple of times, but yeah.
You probably did, but I was probably unfocused.
So they donated the 6 gene edited pig liver to the brain dead recipient. This is from the abstract of the study. Graft function, hemodynamics, and immune and inflammatory responses were monitored over the 10 days. They were able to have goldish bile that was being produced. Your liver does produce bile, which is important. They found that increased. It came up to normal levels. And they also looked at alanine aminotransferase. That was about normal. Aspartate aminotransferase. They increased postoperatively and then declined. The portal and hepatic artery veins, the blood flow was pretty good. They did have platelet numbers decrease after surgery, but they returned to normal levels. So within 10 days, there was no sign of rejection. And they did, okay, so here they do say they did use anti-thymocyte globulin administration. So T cell activity was inhibited. And then they also reduced B cell activation 3 days after surgery by rituximab. So they did actually reduce the immune system's reactivity. Yeah, so anyway, this pig liver did great. There are issues with, pig organs being transferred to primates generally, but this is optimistic, and hopefully soon we will hear about the results of an additional transplantation that they've done inside as an actual transplant, not an auxiliary liver. But the question is, can we use these pig livers? Can we get it to a point where they can either be transition steps before a suitable human liver is available for transplantation, can they work instead of an external like liver dialysis machine? Can they function? Can these pig livers, gene modified pig livers, function to support the health of a human being? And so they're on those steps right now. And this is, I think, very exciting.
Yeah.
Yeah. Anyway, pig livers for people. It's coming to a hospital near you. Probably in several years. This is not ready for prime time yet. What do you want to talk about, Justin?
Nice to know there could always be an extra liver in the future.
Right?
Yeah.
If you need it, maybe there's a pig liver for you. Probably more pig livers than human livers at this point in time.
Tulane University, University of Chicago have demonstrated that search habits and these sort of relevance-based optimizations that search engines do to try to give you good results contribute to a very narrow-minded reinforcement of existing beliefs. And this is one of these things that I think we've already learned, but it's just a study to, systematically look at this. I was once sitting there while somebody was on their iPad and they were like, oh gosh, did you hear this? Some kind of news story that was completely conspiratorial and insane. And I'm like, oh, that's not real. Well, yeah, it is. It's like showing up all over. I'm like, it's because you're at the bottom of a very deep rabbit hole.
Exactly. People don't understand search algorithms and personalization.
You things related to this. It's gotten probably wackier and wackier over time. But I guarantee you, whatever the source of that is not showing up in anybody else's feed.
Yeah.
But basically, that's what this story is about. They sort of found that the polarization effect of people's perceptions of basic factual reality across political, health, economic, environmental, and sociological topics like immigration, that these things are impacted greatly by what a person's previous searches have been. So what they did was kind of interesting then. So they had actually 21 independent studies that they conducted. Total of almost 10,000 participants. And these things used Google, ChatGPT, an AI-powered Bing, whatever that is, and all sorts of other custom-designed search interfaces. And so they had people search for things and see what information they would get back. Participants generated queries on topics of health and finances, politics, and sure enough, when the experiments were controlled based on their previous search habits, those algorithms fed them stuff that kind of matched what they already might have thought. So it was...
so the biases, the preformed biases kind of stayed in there. Yeah.
Yeah.
I like these things. And so you train the algorithm to a certain extent.
Exactly.
To know, yeah.
So then what the researchers did is they introduced a modified algorithm that would give them a broader spectrum of whatever that topic was, of either good sourced stuff or just, other opposing views. And what was interesting is that that broader search was not considered a bad output by any of the users.
Oh, so even though people had a confirmation bias, when they saw other things, they weren't like, oh, that's a lie immediately.
They were put off by it.
Yeah,
they didn't report any kind of this is annoying results or whatever, right? So it's not necessarily that it changed minds by giving the broader spectrum, but it does show that it's not not necessary for user satisfaction by these browsing algorithms, that it only feeds people what they expect.
But
That
so
it's not a service. It's not a positive service or customer-friendly service that's being produced here. It's just an unfortunate negative side effect.
Do you know if they measured with that broader search, which search results were the ones that were chosen? Like, did people just look at the top 10 list of the search results and go, oh yeah, this all looks great? Or did they still tend to focus more narrowly on the things that that spoke to them?
I think they still tended to be a little bit more narrowly focused, but they didn't rate it as less useful or less relevant when they got the broader picture. So maybe they did click through on a couple of things that they might not have seen before. That wasn't really, I don't think, what that they were monitoring that portion of it so much. One of the experiments did look at people who were randomly assigned only to see stories that showed the benefits of caffeine. And at the end of that, they got to pick between a beverage that they would like to have, and those who saw the pro-caffeine literature picked a caffeine beverage. So they did that to sort of illustrate that there is prompting.
The priming
by
effect,
the narrowing,
right?
There's a priming effect that affects real-world behavior. And what I couldn't help thinking about in this is that, does this explain why so many people are being supposedly surprised by the actions that have been taken politically recently? There's a lot of people who were surprised that X, Y, and Z were part of this agenda when it was stated, but so were so many other things.
So I'm going to say the bubbles that people end up in, or these rabbit holes, like you said, where you've trained your algorithms. TikTok, for instance, and a lot of people still get their news from TikTok. TikTok uses content, a content search algorithm, as opposed to a social graph search algorithm. So like Instagram, YouTube, others, they're like, oh, who are the people you like? Who are the people? Who are the influencers? And it's like based on people, as opposed to TikTok. It's what things do you pause on longer? What things do you click on more often? It's very much content focused. And so you can train your algorithm, and it is possible with the social graph one as well. It's a different, the framing of the algorithm is different though. But with TikTok, you can train it specifically. If you go in to your account and decide that you're only going to search for, specific words like "Make America Healthy Again," or John F. Kennedy vaccines, or like whatever whatever it is that you decide you want to create your search terms to be.
It's not terrible.
You can start searching for those things and like clicking on only those things. And if you do focused training of your algorithm and spend time doing it every day or like a couple of times a day, in about a week or two, you will have a new algorithm, and you will have an entirely different world that you are being presented.
Yeah.
And so, yes, this is the long answer to your question. Why are people surprised? And it is because they are not getting the information. And if all the people around them are sharing the same memes, sharing videos back and forth, whatever, and you're not listening to the radio, maybe you're only listening to your music, you're only listening to certain podcasts,
Yeah.
And so if you have trained everything in your life and you don't want to talk about these things with other people, and you've trained everything to give you the echo chamber experience of what you want to hear, you are not going to know what else is happening out there. And this is true for any part of the universe you want to exist in.
Yeah. It's very true. Actually, it's very true of those echo chambers in daytime talk radio that lean far right. I think some of that explains why you have farm heavy industry states that voted in favor of anti-immigration laws because they got riled up about a thing that they maybe aren't negatively impacted by, but quite the opposite, actually rely on a lot of immigrant labor. And so now that labor is gone, they're like, whoa, hey, what happened? It's a weird thing too, when somebody can be convinced to do something that's not in the opposite of their self-interest, even because they've heard the echo chamber. Because
the way it is
formed all of these narrow opinions, because the opposite sounded like a terrible thing.
And the way it's been framed to them, this reasoning, this rationale is in my favor. This is why I want to do this.
Yeah.
Or it is the cognitive dissonance, and a term that I just learned today from a professor who's at, I think, North Carolina State University, affective dissonance, which is the dissonance that you hold for like different emotions about certain things that are in your life.
Yeah.
So you go to work and you're normally a very sad person or not an outgoing person, but you go to work and you act like a happy, outgoing person. And you have to hold all that inside of you, that difference between how you're acting and how you really feel inside. That's affective dissonance. The same thing can happen with, I'm not happy with my job. I don't like paying. What am I doing here? This is bad. You can feel bad, but then somebody else makes you feel good about being part of a club or a team or this group of people who are going to save America. Psychology is awesome.
Well, no, it seems like a lot of rural America has been brainwashed with this argument against the federal government, upon which, like, especially farming industry completely relies. You know, like if there's a farmer in America who's against food stamps or USAID or any of these programs that are fundamentally
going to lead
regardless
to
of where the food
farming
goes, these are farming subsidies.
Yeah.
There are groups of Americans who have agreed that their tax dollars should be spent on farming subsidies. And then what are we going to do with all that food? Well, we have programs and things where we can, make life better for people. But essentially, we want to keep the small farms in existence. People voted against that. They voted against their labor pool. And, like, there's a bunch of, I don't really understand the FAFO anagram. But there's a lot of people finding out the very things that they were voting for are the opposite of their personal interests.
Mm-hmm. Oh no, the tigers are eating my face.
It's leopards, I thought. But yes.
Whatever. It's some cat eating faces.
I don't like that
and you
one.
know
I'm
they
afraid
eat
of big
faces
cats
and you're like,
disease.
they're not going to eat my face and whatever. But this is the dissonance. This is the part of, seeing something that makes you feel good, but knowing that things are happening, that things are bad and they're not going to help you. Anyway.
I don't think that they know that, though. I don't think that they know that until after the fact.
But let's go back to the algorithm. The majority of people do not understand algorithms. And that was a study that came out a while ago that I think we talked about very briefly, which is that's the result. That when you tell people that algorithms are affecting their search results, and you say if you do these things, you're training Google or TikTok or wherever you are, you're training it to only show you certain things. It isn't telling you the truth. It's not showing you the world. And when you explain that to people, they go, what? And they don't like it. And they start to think more critically of the results they're given. So once again, when people are given a little bit of information in which to, start thinking about stuff and come to a realization on their own, then it can help.
So basically, what this came down to, though, what they sort of suggest is a way of improving the World Wide Web is to create algorithms that like you said, that are not locked, that self-adjust.
How about platforms for search that do not allow clickbait? That the title for your listing in their search directory has to be factual, has to reflect reality.
Well, I don't know about that. Maybe my algorithm has already screened those things out, because my searches are pretty darn accurate right now. They usually give me studies. They're like, we're just gonna take you right to the study, not the article anymore. We're gonna just put you right here. So mine's working fine, but it's in the same way. Before Bill Clinton signed that disastrous, what was it, the Electronics Communications Act of 1994 or whatever it was, or 2004. Couldn't have been 94. No, it couldn't have been 2004. 98. Thank you. Telecommunications Act of 1998. Basically what it did is it made it so it repealed the law that made it so that you could only own either like the newspaper or the radio station in town. You couldn't own both and a TV station. You could only have one news source in a particular region that you were in control of, or that a company was in control of.
The big part of this, though, is not just
diverse opinions to be at play.
There was a rule, which is that you had to, in order to be considered like a news outlet, is that you had to offer. That's why we have opinion sections or letters to the editor, or what are called editorials, that these opinions are usually, and like the Washington Post has gotten kind of, people get upset about it. And I'm like, well, it's, you do the news in the voice of your paper for your audience, but then the editorials or the opinion letters are supposed to be contrary. You're supposed to allow a certain amount of space for contrary opinions. And that is actually something that was in law for a while. And it's not anymore. And that's,
but again, I think that was the Clinton 1998 Telecommunications Act.
But that was the big part of it.
Got rid of all of that separation of mass corporatism and media.
Yeah. Oh, media.
But basically, what this study is suggesting is we need something like that, basically, to loosen the algorithm stranglehold on thought.
I know, really, truly, general artificial intelligence, AGI, that's benevolent and wants to help humanity. And I'm just going to stop right now.
Yeah.
Nah.
Have you seen who's at the helm of those things lately?
Yeah. Well, speaking of like whatever and whoever's at the helm of these things. Okay. I love researchers and science because sometimes they're like, I did a proof and I came up with an idea and this cannot be done. And I think we've interviewed this researcher, Kevin Hand, on the show previously. And he talked a little bit about some of this stuff. He's a physicist. But back in like 2016, he and other researchers, Christopher Chiba, they did a simple proof showing that the Earth rotates through the axisymmetric part of its own magnetic field. So you've got the Earth on an angle and it's rotating, right? As it's rotating, the magnetic field, it's actually rotating through the magnetic field. And because of the way that the magnetic field is oriented and the Earth,
for those in the listening
rotating,
audience, Kiki is doing
hand motions that do not help at all.
Trying to show rotational gravitational fields on a rotational object moving through a different gravitational field.
All right. Anyway, we're on a spinning oblate spheroid. It's spinning around. That's the sound.
Spinning around
spinning.
What? 90 million mile away nuclear fireball.
No, that's orbit. That's its orbit. I'm talking about its rotation on its axis. The Earth's rotation on its axis pushes it through, it moves through mechanically through its own magnetic field. And so Kevin Hand and Chiba, they did a proof, and they were like, okay, because of the movement, there are electrons in the atmosphere. Those electrons should get moved by the magnetic field because of the displacement due to the magnetic field. Could we find a way to actually use that displacement to create current, basically energy from just the rotation of our planet? And they did a proof in 2016, and they're like, nah, no, can't do it. You can't do it. It's not going to happen.
Wind farm Earth.
Yeah. But then they were like, we made a whole bunch of implicit assumptions that maybe if these assumptions were different, the assumptions could be violated, and maybe the proof itself is wrong. Maybe
Electric motor Earth. Turbine Earth.
Yeah, generator Earth, dynamo Earth. And so they created a device that they haven't shown. They didn't show it in their paper, which is published in the Physical Review journals this last week. But
according to the chat room, it was a kite with a key attached.
Yeah, exactly. Kind of, sort of. I don't know. It wasn't really a kite. It was a spider with a spinneret. No, they created a device that they tested in a very, very specific test facility, a room in their laboratory that was in the dark so that there was no actual photonic or electromagnetic influence on the system. They created a cylinder that rotates and that moved, and they moved it around with respect to the angle of incidence of the rotation and orientation of our planet and the orientation of our magnetic field. And they moved it around. They're like, does this work? And they're like, okay, we think that it should be in this orientation. And if it's not going to work, blah, blah, blah. And they did it. And they're like, hey, look, we generated current. There was an 18, it was a very small amount of energy that was actually generated. And so it's not like, it's like, yay, everybody, we're going to all be living on dynamo Earth and have free power forever because the Earth is rotating. No, what they were creating, they did generate continuous DC voltage and a current of low predicted magnitude. So anyway, the voltage is 18 microvolts. It's really tiny. It's not a lot.
So does this mean if I'm standing at one of the poles, just in the right position, I might be able to slowly charge a phone off of?
Very, 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 very slowly. And what they did show is with their work is they moved it around. They tried different conformations. They showed they could mess it up and that it wouldn't work. And then in the end, they're like, okay, let's take it out of our very, very special dark room that's isolated from everything else in the universe and see how it does in a house down the street. And it's the same lines, much messier though. So the signal of the current is noisier, and that would have to be fixed. But what they are questioning now, they want other people to replicate their experiment. They said, okay, we did this. Did we do it wrong? The math is right. Everybody likes it so far, but can anybody else replicate it? So that's what they want, our other teams to replicate it. And then if it can be replicated, can it be iterated? Can it be changed to create more current? Or can it be changed to, I don't know, could it slowly charge a battery? How could something like this trickle charge over a long period of time small devices? Or, I don't know. It's very interesting. They just moving this cylinder around of this magnetoferric material allowed them to disperse the electrons in such a way the current from the rotation of our planet through the magnetic field. Great. Oh my gosh.
That's pretty cool.
yeah. So this is one of those wackadoodle things where you're like, what? How did that happen? Okay. And they said it couldn't happen. And I love that they were like, oh, we did the proof, said it couldn't happen. And then we tested it and we did it. So congratulations to Kevin Hand and his teammates. I think it's pretty awesome. And I look forward to seeing what people do with this, like whether it's something that people move further. And is this something that, for things in orbit that are moving faster and through the magnetic field, is this something that could be used there? I don't know. I find this a fascinating subject. Maybe we'll get Kevin Hand back at some point to tell us more about it, if he maintains his government funding.
Well,
what do you want to talk about, Justin?
Government funding.
Yeah, I know. That's why I said, I know.
Yeah, there's a lot of the FAFO stuff going on. What was it? Were you the one who was telling me about the entire state of Alabama being like largely, like Alabama University being like the state's #1 employer?
Oh, yeah. Yep. And I think that was originally published in Science several weeks back, but yeah.
Yeah.
Yep.
And their funding cut is now like, hey, we voted for this. Why are you hurting us?
Billions of dollars. So thousands of jobs, tens of thousands of jobs. Yeah. It's just, yeah. Okay, what's happening now?
So this is something. National Institute of Health and the Department of Health and Human Services funds a lot of research. And they have these, what are they called? Notices of funding opportunities. So they put out these these aren't like direct, like it's not so much you have come to them with your grant, you want to study this. These are panels of scientists saying, hey, you know what would be great to have somebody look into? Would be this or that or this other kind of research. We want to fund research into, this type of bacteria or that type of virus or whatever it is. This type of disease, this type of ailment, we would like to see this, that, or the other looked into more. So they have these notice of opportunity, funding opportunities that they put out. Now, normally by this time of the year, they would have put out hundreds of these. But there's been a freeze on communications already. So they haven't been putting them out. And they've just been informed that they will be able to put out these notice of funding opportunities. However, they will now first need to be looked over by a representative from Doge?
Yeah. Department of Governmental Efficiency.
Which was a meme coin, as I recall.
Yeah, yep.
The one with the dog on it.
Mm-hmm, yep. Mm-hmm.
Which is backed by a billionaire who is now apparently in charge of a government not organization consulting thing, something, like undisclosed, unelected bureaucrat who's still not in the government. Impossible to define. But these panel of scientists created funding opportunities to look into things are going to be thumbs up and thumbs down by this weird parasite on our government. So this is the thing that nobody on that team, I think, is going to understand. So I'm going to try to use a sports analogy because sports ball is a thing that's popular with a lot of people. Football. I'm a big football fan. Football. Last year, we had 2 teams that made it to the final big game. Right? There was a lot of teams very early on, some would say even before the season began, we knew, this isn't going to be their year. Should they not play? should all the teams that it's probably not going to be a winner this year, should they just not play next year?
Why bother?
Why play those games? Why spend all that money on uniforms and television and bringing the crowds out?
Why do we play games anyway?
They're not going to win.
Isn't it only to win?
They're not winning this year. Oh, they're in a rebuilding year. Maybe they're gonna get better. Yeah, but let them practice for 2 more years somehow without putting on a uniform or being in front of a crowd. Well, obviously those teams aren't going to survive that because they won't have revenue. All of science doesn't win this year. Get that. Some of the science is going to be like, Cincinnati for the next decade and probably not get anywhere close to a real victory. They need to still be in the game. Because Philadelphia just won the Super Bowl. They wouldn't even be in the league based on their record for 20 years before, right? So, this is the thing with science is you can't pick winners and losers just based on one study. You need the breadth of science, and especially research that is being chosen by a panel of scientists at the National Institutes of Health that they think needs to get looked into further. There should be no uneducated decision making that is influencing that. Because I can tell you.
I think
Cleveland Browns shouldn't even suit up next year.
I think there should be different members.
Should they play?
There should be different members on these panels. I think it should be scientifically decided. But I'm also of the opinion that these scientific studies that are funded, they should be, in humanity's interest. That they're not. I don't know. I love Dr. Demento, but just the name popped into my head. They're not just I don't know, some mad scientist vision of the future. I'm going to do what I want because I have money. Ha ha ha. Fruit flies. Ha ha. Yes.
I'm not going to say, go launch yourself to space. Fine.
Mm-hmm.
Fine.
But not all research can be private and within corporate enclosure. The majority of research, it benefits humanity. We need to fund it publicly, and we need that data to be publicly available and the research and the results to be accessible by the scientific community for the betterment of our understanding.
And it's worth funding bad science. Listen.
It's worth funding all of it.
It's worth funding some bad science along the way too. Because here's the thing. It's the same thing with having that farm grow soybeans in a year where soybeans aren't going to be that much in demand. You might pay them not to do it in farming. That happens. But it's a way of keeping the small farms alive so they're there when you need them. And maybe they switch crops the next year and do something else. Mm-hmm. But you keep them running because they're a crucial part of our society. Same thing with the researchers. Hey, you know what? Maybe we don't need everybody who's doing research on bird flu 20 years ago. But boy, we're glad that they're doing it.
And we're glad they're doing it, and they haven't stopped.
Right. So there's always going to be a need to keep those researchers practicing, improving, adding to the conversation.
The diversity
big hits of information that we didn't know.
Yeah.
They didn't expect to come from. Because it's the big discoveries typically don't come. The woman who basically created the mRNA vaccine that helped save millions of people from dying from COVID couldn't get tenure at her university.
Madeline Carrico, something like that. Yeah,
couldn't get tenure at her university, and still
didn't she sleep in her car at one point? Like there's I don't know, there's stories of her being very financially
that I don't know.
impoverished. Like she was not like, she was not living high on the hog and researchers, they get paid all this money to do this work. She was not. And but her work, she kept going, kept trying to get funding. She persisted.
And we need to fund these things. So I'm not surprised.
No Dr. Evils, Kevin Reardon. No.
I'm not disappointed in this government because it's meeting my expectations. Really?
Oh gosh. Yeah.
I mean, it's just like
it is exceeding the expectations.
I'm not surprised at all.
Oh.
But for those who are, check your algorithms, because that's probably how you didn't see it coming, because all the information was out there. This has been talked about. Some of it has been talked about for decades, what they're going to do. Like, we haven't even gotten to the actual changes to Social Security yet.
That's not science. That's not science, though, but we're going to keep going. It's fraud, I know, but...
Taking money from the government's fraud. But it's our money. What are you talking about?
Yeah, we can talk about that in the after show. My dad had a great comment that he posted on the Book of Faces. We'll talk about that. Yeah. Interesting. We'll talk about that after. I'd like to talk about glucose very quickly.
Oh, I thought we were going to go transition to the break. You got something about glucose. What's this?
I guess it doesn't fit at all, but I wanted to give something incredibly science-y before we go to the break to remind people, about the science that we like to talk about here. The stuff that's being funded, that should be funded, that's helping. This came out of Stanford Medicine. And this is one of those wonderful studies. Peter Kavari, chair of dermatology, he's the Carl J. Herzog Professor in Dermatology in the School of Medicine and a member of the Stanford Cancer Institute, is senior author of this research that was just published online in Cell Stem Cell. Graduate student Vanessa Lopez Pajares, or research scientist, already PhD, is the lead author in this. They ended up finding out that glucose is a big, big part of cellular development and differentiation. So the process by which cells go from being, I'm a stem cell, into I'm a skin cell, or I'm a hair cell, or, whatever it happens to be.
They all sound the same. I love the fact that you gave none of them any differentiation when it came to their accent.
Right.
Even though the cells themselves were very obviously different cells, they sounded identical.
Well, I'm a skin cell. I'm a hair cell.
There we go. That's what you expect from a hair cell. You expect a hair cell to have a little gravel in the voice.
Hairy voice. I'm a hair cell.
Yeah. There you go.
Just waiting for that razor. Shaves up. Anyway, these researchers at Stanford Medicine were not focused on glucose when they started their work. They were looking at cellular triggers or cellular molecular signals that helped to create the differentiation into different cellular types. And when they did it, they were like, we're going to look for all sorts of things here, different signals. And they expected, they saw like 190 different things that they were trying to parse and figure out what was going on. But glucose kept increasing in concentration inside the cells, even though they had hypothesized that glucose should be decreasing because of the energy being used for differentiation, and that the glucose would be getting used up and wouldn't be getting concentrated. But glucose kept going up. And so then they're like, wait, this is weird. Okay, now let's look at it. And we're going to specifically do markers that are fluorescent markers to check for glucose. And they're like, man, the glucose is really what's going on here. And then they checked with glucose analogs, and they were able to see that the glucose analogs got involved there. What they ended up finding What do you normally think glucose is for in cells, Justin?
Oh, it's an energy source of cells. They basically absorb it, devour it, eat it, however you want to say the cell uses that, transforms it into energy.
Yeah. So glucose is taken in by cells. It's part of the metabolic process, the Krebs cycle, right? Glucose comes in, it gets turned into carbon molecules. It gets turned into food. It gets turned into the building blocks that the cell uses to create stuff. So you'd think glucose is going down, but they're like, nope, it's lighting up. It's getting light in there. What's going on? Turns out that glucose is grabbing onto some molecules on the outside of the cells. And they found that it's grabbing on specifically to a particular signaling molecule that once it grabs onto it, it changes the conformation of that signaling molecule, and the signaling molecule goes, hey, everybody, differentiate, do your thing. But glucose is like, I'm going to hang out here. It's not being used for energy. It's not being stored. It's signaling that it is time to grow. It's glucose as a signaling molecule, not just energy. And so now they're looking at this whole finding in the light of glucose dysfunction. So what is happening when you have too much glucose in your body with insulin problems, right? With diabetes, or you have too much glucose building up, you have too little glucose in your body. What does that mean for the tissues of your body? Not just for the food, not for their fuel source, but for actually their ability to repair themselves. And they did find that a bunch of glucose analogs had similar impacts. And so what they're going to look at a whole bunch of different things related to glucose to see how they impact. And what I'm wondering also is, what does this mean for fructose? For, when we're talking about the different kinds of fructose, if they're slightly different molecules, if they're not just fuel sources, but actually acting as signals, what does that mean? And so this is a whole different question that I hadn't ever thought of before, but I don't know. What is it? The high whatever syrup fructose that they use in soft drinks and everything, that everybody's like, this is so bad for you, but nobody can really figure out why. Why is it so bad for you compared to regular fructose? Anyway, I think it's quite interesting. Yep. Glucose. It's more than just fuel for your cells.
Yeah, no, that's a really amazing, thing that you would think with all the study that has been done already to this point, figuring out how the glucose interactions with insulin and the resistance, how it's getting absorbed and not absorbed, and trying to control that system for the diabetes diseases, which is a whole thing.
Yeah. And it opens up a whole different idea of how we coexist with the bacteria in our bodies. Is glucose, if it's acting like this as a signaling molecule with our cells, is it also a signaling molecule with the bacterial species that populate our gut?
Or in cancer.
Cancer. They're not just dermatology, it's the Stanford Cancer Research Institute. And so, glucose is a huge trigger for cancer, but we thought just for fuel, right? How else? Differentiation. Yeah. That's growth of a tumor potentially, right?
Yep.
Yeah. So, I don't know. I find this absolutely fascinating, and I can't wait to hear more about these sugars that we thought were just sugar and energy, and how they actually how they work in a much different frame when they get bound up by a signaling molecule instead. Yep. That's the kind of science That is the kind of science that I want to talk about it, and I want it to be funded. And we have to talk about now. Okay, is it different in different populations of people? Is it different in men and women? Is it different in different uh, ethnicities? Like, how does it work? We got to figure out these mechanisms. Best for all of our health, for a healthy society. These are the things I want to talk about. These are the things I love talking about, and I can do it thanks to you, our listeners. You support this program, This Week in Science. We are not federally funded, so we can continue talking about the science that we want to talk about. Head over to
Well,
twist.org.
although we do need the federal funding in order to have something to talk about, so call your congresspeople and your senators. As soon as you're off this, the show is over, get on the phone and be like, hey, I need my science.
One ringy dingy. I need my science. That's right. I'm a stem cell. I'm a hair cell. I need my science.
Otherwise, we'll have nothing to talk
about. I'm sure you will always come up with something to talk about, but we like talking about things from an evidence-based, research-based perspective. What questions are people asking out there, and what are they finding, and how is it changing our view of the world? Thank you, all of you, for supporting the show. Patreon account is at twist.org. You can go to twist.org, click on the Patreon link. It'll take you to Patreon, so you're going to bounce to a different place. But at Patreon, you can choose to support us at any amount, $10 and more. We will a month, and we will thank you by name. There are other levels that'll get you a T-shirt. Others get you stickers. There's a few different things. Somebody please remind me to update the stickers so that we get a new batch of stickers out this year. Additionally, we have our Zazzle store. Zazzle is where we put all of our TWIS merchandise, and so you can get T-shirts and hats and other stuff. It's not in a subscription basis the way that Patreon is, but it still supports the show. So if you go to twist.org, click on the Zazzle link, you'll get to see our store, and you can find all sorts of awesome stuff. Summer in the Northern Hemisphere is coming up, so if you're into it, the bath towels, not bath towels, the beach towels are really amazing. I really like mine. Sweatshirts are good too. I've had mine for a few years now. Really like it. There's some great stuff on there. It supports the show. The big thing though is if you can just help get people to subscribe, bring us more listeners, bring us your friends, subscribe them, whether or not they want to be subscribed, surprise them for their birthdays. I don't know. We would love to have your friends here too. Wouldn't you like to have those conversations? Don't keep it to yourself. I know you want to be the most interesting person in the room, but
you already are.
There you go. You already are. Yeah. You can afford to share a little. Thank you all for all your support. We really cannot do this without you. We're going to come back now. Unfortunately, no Blair's Animal Corner music because there's no Blair, but Justin, what do you have for us?
Why does mine sound like Deliverance? Why did I get the Deliverance soundtrack for the Justin corner? Well, you know what? Fine. That's fine. Here's Justin's Animal Corner with Deliverance music. Good grief.
You're welcome. What you got?
Assumptions.
Oh, always. Okay.
You know what they say about assumptions? They make genomic diversity, conservation, an illusion when you rely on assumptions. That's what they say. This is researchers from the University of Copenhagen, who we presumably will still be able to report on for a long time to come, for research coming out of other countries. They have found that critically endangered regent honeyeater faces hidden genetic risks. And that hidden risk has to do with a decline in population combined with a lack of a genomic loss, which seems like it's a very sort of unintuitive thing. This is a population. They went back and they've tracked genomically this bird back to 1919, so a little over 100 years, pulling samples out of museums for DNA, getting current DNA. and tracking the sort of genomic history of this bird for the last 100 years. And this bird, over the last 100 years, it's actually been a lot longer than that, but has been going through a population decline. The population has declined by 99%, down at one point just to 250 mature individuals remaining in the wild. So brink of extinction.
Yeah.
In this sort of a scenario, there would be an expectation that the genome itself has also begun to sort of, for lack of a better word, collapse, right? You expect it to become highly isolated, or become very homogeneous, very much the same. I'm missing the word I'm looking for, but with inbreeding, with a small population, you would expect that genome would start to shrink, become less and less diverse. And if there were any sort of deleterious genes, any sort of ailments that were genetically
they'd start to show themselves.
That they could really show up. That they're one of those that manages to make it into that shrinking pool could really take over and then accelerate that decline. So they went and they did the study. They looked at the entire genomes of 44 of these birds going back over 100 years. And actually what they found is that this bird has managed to avoid. It's lost about 9% of its diversity over the last 100 years, despite losing at one point 99% of the population. And what this shows is that you cannot judge the critical nature of a population just based on the genome. And this is something that has been used in conservation efforts, where they kind of got to show, look, this population gene pool is now shrunk to the point where there's inbreeding and this sort of thing. And these are songbirds, I think, from Australia that have a nice big territory. So even though their population shrank, they had been so dispersed over time that there was probably a pretty good diversity within that gene pool.
Yeah.
But they're saying, yeah, there's still reasonable amounts of admixture. Doesn't look like there's any increased inbreeding, and the gene pool is shrinking. The diversity is dropping, but it's not dropping at the same rate as the population. And so that's all it is. It's just a lesson in not overjudging your need for conservation based on genes alone.
Okay, so the population might come back a little bit, but the diversity won't necessarily. So the population number isn't indicative of the deleterious aspects of the genome. That they're not exactly tied to each other in a one-to-one relationship.
And again, though, this is birds. If you were talking about turtles that all have the same breeding ground on an island or something like that, then maybe the population decline would match quicker time. But in this species that they're looking at, there's a big lag between the genome shrinkage and the population decline. And it's
also, I mean, songbirds, the majority of them are within a year or two at maximum, usually are within their breeding maturity, right? So they're juveniles for a very short period of time relative to how long they are adults. They don't have long lifespans, but they're definitely not fruit flies, So, and I think you're right about the importance of certain things, like the ability of an animal to get away from certain environmental factors. So you might have deleterious genes, but because you can fly away from the place that's cold and you can't keep yourself warm, or you fly away from the place where there's the predators that are eating you, suddenly you can stay alive longer. Whereas, like you said, like turtles who are just stuck on a beach or whatever it is, they're not going when the animals environment and the way they live in the world is constrained, that's going to have a big impact as well.
Which is actually what happened to these birds, because their population breeding habitats are almost all in Southeast Australia, and like those are expected to be nearly gone by the year 2040. So that's why it's people moving into those areas in Australia that have ruined the habitat of these birds, or the breeding habitat.
Oh, and by the way, now that you said that, tangentially related study out this week, pretty much the decline in diversity in species around the world is based on human activity. Woo!
What?
Yeah. A new study looking at diversity of species in a big sample of locations around the world found that the decline in species diversity in basically every single spot was because of humans.
Oh, fun.
Ta-da! We're awesome. We had so much impact on the earth. Look at us. No, it's not awesome.
Oh, but we're going to turn that all around with the green economy.
Oh, are we? Can we?
Yes. Okay.
All right.
So here's an uplifting story. There's a place called the Lithium Triangle down in Chile and Argentina and Bolivia. There's a sort of area where more than half of the world's lithium resources apparently are underground there. And lithium is a weird thing. It's a metal, but it's super water soluble. So it tends to occur in layers of volcanic ash, but it quickly reacts with water, and then it'll move with rain and flood, and it sort of leaches into the groundwater, moving downhill until it finds like a kind of flat, rocky basin where it can remain as a solution of a briny mix of water and lithium. It's very dense, and it settles beneath the pockets of fresh water, fresh surface water, quite often. So one of the ways that they tend to mine for this is they will dig it up and then let the water evaporate, and then they would harvest. That's back when we used a little bit of lithium.
A little, yeah.
Now
do we use more lithium now, Justin?
Yeah, there's a little bit of high consumption of lithium. I recently bought a bunch of lithium. Yeah. I recently bought quite a bit of lithium, along with some iron and some phosphate. But
did you get an electric car?
No.
Okay.
But I don't have a car that runs on electricity, but I have a car that makes electricity.
Oh, good. Okay.
So, so anyway, they're basically have created new methods of mining. Basically, it's like fracking. It's like fracking lithium. Ways to get high amounts in shorter periods of time. And according to this, where was this from? According to this research that is published in Communications, Earth and Environment from UMass Amherst researchers, we have underestimated the amount of fresh water that we're using to collect this by a magnitude. Basically, it's using 10 times more water than the estimates, because the estimates are all based on the old mining methods.
Oh.
Not only that, because the lithium tends to be found under freshwater deposits that are naturally there, they tend to be below very fragile ecosystems. So we are destroying ecosystems in very remote parts of South America that haven't been destroyed by humans yet, because very few people are living there. But now, because of the green economy, where we're going to solve the world's problems by not destroying the earth, we're destroying the earth.
Yeah. I thought this was supposed to be uplifting, Justin.
Meanwhile, deep sea nodules.
Oops. Sorry. Yes. Deep sea
We're going to be
nodules.
getting a lot of these precious metals. Also can be found on the bottom of the sea. Well, I don't know about lithium. They've got different kinds of metals down there at the bottom of the ocean, and these nodules. I'm not even sure what a nodule is. However, it turns out they may be producing oxygen. And they cover the bottom of the sea. This isn't a different study, but there's an estimated 21 billion tons of nodules on the seabed of the Clarion-Clipperon zone, which is something about 25 times the size of the UK on the bottom of the ocean. People have been talking about mining this for a long time.
Okay, so this is the other issue, right? Is we've got the nodules. It's creating oxygen. People are talking about mining it. Deep sea mining is going to be a problem if it is not regulated. And
But that's
right
where
now,
we're going to get cobalt, magnesium, nickel. Huh? We need those for an electric car.
and some of them
economy.
are biologically, or the chemical processes that are happening in the same places as the deep sea vents with the black hot smokers, where they're these rich, microscopic populations, ecosystems, and that's because there's nitrogen fixing. There's like these trace metals, these heavy metals get pooped out by little bacteria down there who are trying to live in the dark, trying to deal with this stuff coming up in the water. They're using it as fuel. They're using it for their metabolisms. But the nodules, they're great. That's awesome. It's kind of like the iron the bog iron. You know, it's bacterial, it's stuff, it's very slowly produced. But because we haven't touched it for 3.5 billion years, 4 billion years.
and the good news is it may, after we mine it, it may only take several decades to recover. In the meantime,
yeah, several decades, because nothing can happen fast.
Those ecosystems may never recover either. And we don't have it studied properly, so we don't know how they're connected to the other rest of the ecosystem that is the ocean, life form, energy,
it's
oxygen
essential.
producing.
I'm sure it's essential to life on the planet.
That is most of the. It'll be fine though. You know how I know it's going to be fine? Because by the time the consequences come, I'll be long gone. This will be all the future generations' problems, and that's why I don't care.
And you're
but I've got
you have kids.
So do you.
Yes, we have kids.
The future is important.
Yeah, yes, right.
There's no escape from consequence.
I believe
behavior.
the children are the future. That's right.
How do you escape the consequences of being human on planet Earth?
You cannot escape the
line.
consequences of your actions. You can only ignore the fact that there are any until it's too late.
There we go. That's the path. That's how we'll handle it.
That's how we'll do it.
Everything is fine. Well, so anyway,
I have
these
news.
are these are the trade-offs that you're going to have to make to get off the fossil fuel economy. There's energy consumption is the thing that humans need to do. It's what keeps humans rolling, and we're going to need more of it because there's more of us, and it's going to have to continue like that for a very long time.
Sidebar, if you are going around and setting fire to certain electric vehicles right now, just think about the
You can
toxic
see me.
smoke.
You can tell that I'm
not. I'm saying you, as in the general public who may be listening. I don't know who's listening or watching, but as a statement politically, yes,
Don't be
we
an
get
arsonist?
it.
Is that what you're saying?
Yes, there's the damaging of of property, these vehicles that are a statement because they're connected to certain individuals who are running your dodgy department in the government. The connection is there. People see it, but those cars were bought by people who wanted to do there was fanboyish stuff going on there. Certainly there was psychological stuff, but those people also wanted to do something that was new tech, that it also could be good, that they're buying electric vehicles to be good for the planet, that they're buying into something that is a transition to something better. And so, slap a silly sticker on a car if you want to deface it. Don't blow it up, please. It's not helping. It's not helping the planet if that's your, gosh darn it, I need to fix this. If that is your rationale, that you're making a statement for the planet and this person's bad for the planet, if you're just mad at a person, whatever. But if you're trying to make an environmental statement or something related to that, you're going down the wrong path. But anyway,
can I just
I need to
throw
talk
something
about
out
the
there?
brain.
I have to throw something out there
Really
because you
need
said
to
this.
finish the
because
show.
you said this. Nobody has been arrested for making a statement by arsoning those vehicles that you're discussing. However, a lot of those fires happened at dealerships that aren't privately owned like most car dealerships are.
Absolutely.
They're corporate dealerships.
Yes.
And their inventory is catching fire after demand for their product.
There's no
fell.
people.
Hang on. You're not hearing me all the way through.
No, demand for product falling. Okay, I hear you.
And then the product caught on fire? Oh, is that how it happened? Oh, I wonder if you're getting insurance for all of those cars you couldn't sell all of a sudden.
We are not saying that this is a
But we aren't
question.
saying the other thing either then.
No, these are rhetorical statements.
Okay. So that was your rhetorical statement. My rhetorical statement is nobody should be burning down their products that they can't sell to collect the insurance money. Nobody should be doing that.
It's true.
Nobody should be setting fire to an entire dealership worth of cars that they can't sell because they want to get recouped for the expense. Nobody should be doing that. I just want to make that clear to the audience. I don't know where you are, but if you own a dealership of your own cars and you can't sell them, it's not okay to set them on fire.
It's not.
I just want to make sure that we've top-explained everything in a way
Thank you. Okay.
that is clear to our general listening audience.
Yes. Hypothetically and generally, yes. Okay, we're going to move away from that and let's talk about brains for half a second and memories.
Brains. He made me switch tunes. I'm sorry. Find the mute button. I know the mic. Wait, here we go.
You don't mute yourself. Be here always.
It's
all
even
right.
relaxing to me to have the mute button on. So I'm just.
All right.
Gonna...
It's good. It is relaxing as long as I stay relaxed because you remember to turn it back on later when we want to talk more. Anyway, 2 studies out today: the opposite ends of life, babies and aged folk. A study that is functional magnetic imaging out of the journal Science. Researchers have just been publishing their work on infants or aged 4 to 25 months, so almost over 2 years old. So little babies to almost over 2 years old. And 4 years is pretty good that's post 4th trimester kind of stuff. So they used fMRI to scan the brains of these infants and had the infants complete a memory task. This memory task involved showing the infants pictures of faces, scenes, and objects. And then those were followed by the memory test, which is based on preferential looking, where the infants, because they've seen something before, they're like, and they look at it more. They're like, I like that. I know that. Or they look at the novel one and then they go back to the one that they like. This happens. Novelty is really big, but in infants, it's very common for infants to really like the things that they're learning about and that so once they see their parents' faces, they want to look at their parents' faces. And as all their senses come in and they start to be able to focus closer and further away, they want to be able to, the baby brain wants to be able to identify its parents and those important things. But the big question is, at that early point in life, some people say, man, it's like around 2 years old, 3 years old, somewhere around there. I wish I could remember what it was like to be a baby, what I could see. I don't remember anything. And then some people are like, oh, you know what? I remember everything in the womb. They can.
So literally, this is one of the spookiest moments I remember.
That's right. Your child, right?
No, it wasn't my child. Like, I can remember like a lot of like super early stuff. But this wasn't my kid. This was a friend of the family's, and he was kind of a bright kid. And we were having this kind of a conversation, and somebody asked, like, oh, well, what? I think the kid is like 5 or 6 at this point. It's like, oh, so how far do you remember being a baby? He's like, I can remember being inside my mother. And everybody's like, oh, really? And what did that sound like? And he just goes, boom, 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 boom. And everybody was just like, wow, just floored. Like, everybody there was like, oh my gosh, that kid remembers.
And that kid now will remember it for sure, because the kid recalled that during a period of time that is when the brain is actively supposed to be able to make long-term memories of things, right? So this kid, that memory may be something that is tied in, very, very cemented into their memories now. But this particular study, they were looking to see what was going on, functional magnetic imaging in these infants. What was happening in the brains of these infants as they looked at the new stimuli and then looked at stimuli that they'd been exposed to previously versus not. And so with all this, they found that the infant's hippocampus can start encoding individual memories at around 12 months. So that's why most kids, even though the ability to form memories starts early, the temporary nature of them is this amnesia, what they call infantile amnesia, is actually more due to retrieval failures. So there might be stuff in there from as early, and if your hippocampus was a precocious hippocampus and got its start early, maybe you can remember things from a younger period than other people. But the problem is it's in there, but your brain is not set up to actually retrieve that stuff because it's more procedural. It's procedural memory, not factual memory that is, or, the retrieval memory of being able to tell a story or explain something, understanding like the feelings, the senses, stuff that was happening. Those kinds of memories are not, they're in there, but your brain wasn't set up for that retrieval yet. And so that's basically what it showed. Early in, the hippocampus can store it, but the brain is not set up to retrieve it. Those pathways are not.
Again, I guess, and that if it hasn't been retrieved in 2-3 years,
it's harder to retrieve.
Then it may not.
It may never
be there, or the connections to it might have been isolated, or can you rewrite? Can you overwrite? I don't even know.
You absolutely can overwrite.
Okay.
Yeah, but it's very interesting, and apparently this also aligns with rodent studies. So little babies, the brains are working like rodent brains in the way that this seems to work. So the inaccessible nature of the memories is the interesting thing. So what I'd love to see is whether they could. They can't experiment on babies to this extent, but how do you create a situation where retrieval becomes possible? I think that's an interesting question.
Somebody keeps sitting on their keys. One of the neighbors.
One of your neighbors. Honk, honk. It's good. It's all good out there. On the other end of the aging spectrum, we have the aging brain, and the deteriorating brain becomes more and more dysfunctional as it ages. And there's a question of, how could we potentially fight off Alzheimer's, dementia? What are the causes of the loss of memory as we age? So when we're young, our brain can make the memories, can't retrieve them. As we're getting older, we've got the memories, we've got the retrieval, the systems are all there, but what's going on? Well, this study out of Washington University Medicine, they've just published a study in Cell, and meningeal lymphatics microglia axis regulates synaptic physiology. And in this study, it's not in people, it is in mice. And what they were able to show is that in the meninges, the lymph system, the lymphatic system, which is like the drainage system, it's the system that gets rid of, all of the waste material from the brain. It's supposed to flow through and clear everything out. It's a fluid that just flushes everything out, takes the bad stuff away so that that can go be processed by your kidney. And they discovered that the meningeal lymphatic system becomes dysfunctional with aging. And as it becomes more dysfunctional, the microglia that that are mediated within this system, the microglia then start to release interleukins, or inflammatory molecules that change synaptic connections and change behaviors. And so they were able to show that these aging mice had bad memories when their lymph system was starting to deteriorate. But then when they flushed everything out and fixed it all up, their memories got better. And so it's this, we've talked about it before in the show, but now they're making a real connection between this lymph system, the meninges, which are it's like the skin of the brain inside, and these meninges and the blood flow, the lymph flow, the microglia, those supporting cells, and their little local, cell signals, and the health of the brain. So perhaps if we can keep the waste management of the brain up to par, then we can age healthier with our brains in better functioning form for longer. We will see.
Wait, how do we do it though? I want to brain cleanse.
And how do we get a brain cleanse? Well, right now it's not for you. It is only for the rodents. At this point in time.
They get all the good stuff.
The rodents get all the good things. It's amazing. It's fantastic. These mouse models, they don't have Alzheimer's. They don't have dementia.
Bunch of good-looking mice running around.
I know. What about the sharks? Did you hear about the sharks?
You were telling me sharks talk? Is that what you were saying?
Yeah. Have you ever heard of sharks talking?
No.
This is a study I wish Blair were here for, and I bet she would have brought it this week. But researchers publishing in Royal Society Open Science, their paper, first evidence ever of active sound production by a shark. Sharks are silent. They're predators usually. Not always, but the jaws sound is not a sound that the shark makes.
That'd be terrible. There's a shark.
It's a shark. It's coming. Yeah, so that's not a sound that the shark makes. So the question is, do sharks make sound? And people have seen rays and skates, other elasmobranchs, sharks are part of the elasmobranch family, making clicking noises, having calls. And there are usually, like if there are predators are around or if there's danger, there is some amount of these sounds that sometimes it's incidental from swimming or feeding or whatever, but they have shown that there are these clicks that some species can produce. So, cowtail stingray produce clicks when approached by divers. 3 batoid species, the blonde ray, the rough skate, and the marbled electric ray, they have short broadband clicks when they get disturbed by divers. The researchers looking at the skates and the rays, they think of this as like, okay, ooh, it's disturbance. The animals are disturbed, and so they're making a sound to tell others like there's a disturbance, there's a threat. It could also be a clicking to warn what the divers, whatever is disturbing them. But I think it's more so to talk to each other to say danger, 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 danger. I'm not happy. I'm not happy. I'm not happy. And so these researchers were like, I think we've got this going on in sharks. Let's take a look at sharks. And so then they were like, let's take this one species of shark that is tiny and we can hold it in our hand and it's really sweet and it's nice and we can have it in the laboratory and it's great. And we can just do the science. And yeah, okay, we're going to use it as a model species. So this is great. So they looked at a particular type of shark known as a rig, Mastellus lenticulatus. Mastellus lenticulatus. And they observed that there were consistent clicking sounds when they are handled underwater. And in this particular study, they showed and they were able to record the first instance ever of captured sharks captured making active sounds for the first time. So I'm going to see if I can create a situation for you all to hear the clicking, and then we can talk about where the clicking came from. How would sharks, little tiny sharks, make clicking sounds? What do you think, Justin?
What are like I don't know. It's some sort of cartilage click thing that they got going, because that's all I can think of is that they're all cartilagey. And that they could have a little clicker built into the tail or something that they could wiggle. I don't know. What else has a shark got? Teeth? Are they gnashing their teeth? I don't know. Is it? Oh, jaw popping.
Jaw popping.
Yeah.
So it's teeth. What they ended up finding in this is that the sharks that they handled, that they were kind of clacking their jaws, and that there is it's a clack. And if you can imagine these little sharks being super upset and being like, I'm going to bite you. I'm going to bite you.
Yeah. But I feel like that's just what sharks do. Like, does it have are they communicating anything with the sound to each other? I mean, it's just.
And that's the question. Is this just because they're upset? Or is it because they are? Is it because they actually are trying to send a message? Can you hear that? Tick tick.
Oh yeah, I couldn't hear any of the clicking. It has to be way louder.
Okay, I'll see what I can do. But it's not a fancy sound. It's just kind of like a. And that was me with my teeth.
Now, was that you trying to say something, or were you trying to bite the audience? Like, what was happening there? I was trying to
bite my microphone. I am disturbed tonight. And these little rigs, they can grow up to about 150 centimeters. But they are tiny animals. They're very cute. The babies are adorable. You can hold them in the palm of your hand. They look like fishies. They are fishies. These little sharky fishies. They're fantastic. The researchers say they at first thought it might be a strange artifact. However, with time, as the animals got used to the daily experimental protocol, they then stopped making the clicks altogether, as if they got used to being in captivity in the experimental routine. And this led us to consider that maybe we are observing a sound-making behavior and not a strange artifact. So how they're the teeth of these animals, I think it's not the same kind of situation as a clicking of teeth that you would think of for us with me, biting my teeth down. Remember, sharks have rows and rows and rows and rows of teeth. And so they're probably rubbing their teeth across each other in some way, the same way that you could like rub your thumb across a comb or a hairbrush. Remember that shark teeth are very similar to, I don't know, like snake skin with all of.
They're a form of scale almost, right?
Mm-hmm. Yeah. So they're probably rubbing instead of chomping.
They don't have a choice but to make that sound.
That's the only sound they've got.
I mean, I don't think they can avoid it.
I rub my teeth together at you.
I mean, the idea that sharks aren't completely silent doesn't blow me away. But I thought they were talking. Now I'm not. I don't know.
They might be talking to you, saying, "Don't bother me."
I still can't hear anything from that audio you're playing. None of it's coming through.
All right, hold on. I keep trying.
I don't think the audio is turned on. The video part I can see. I can see the screen, but I don't think the audio is tied into our audio.
Well, let me try one last time. It's not very loud because it's a little tiny shark and it's a little clicking noise. Wait, hold on. Stop sharing. Try again. Sound, people. Once upon a time, I used to know how to do things like this on the internet. It says also share tab audio. I'd like to share a tab audio. That's great. Let's do that. Here we go. Share. Also share the audio. Come on. There's water. There's click, click. Little click. Click. It's like little. So quiet. Here comes a big one in a little second. A swish, swish, swish. Here comes it. It's too quiet.
But I could hear it that time.
Did you?
It played.
Okay, yes. Great. Fantastic. Fantastic.
My shark is not as good as, well, it's about as good as any other of my language. But it sounded like it was saying, "Put me down, put me down,
I think
put
that's
me
what it was
down."
saying. Yeah. So from now on, when I'm feeling disturbed or bothered, I'm just going to, and everybody know, put Kiki down. Just put Kiki down. Have we done it? Have we come to the end of our show?
I think we may have. I'm out of stories.
Me too. I mean, I have more stories, but I'm not going to talk about them. Like a big, long organic molecule found on Mars that's as old as life on our planet.
What?
Yeah, so it suggests that the building blocks of life have been around on Mars, like the really big, complex ones, been around on Mars for as long as life has been on our planet. So, bingo, bango. That was one. Oh, another one, we might be underestimating the number of people on the planet because we use a grid system to estimate the number of people in rural areas that are not covered by censuses. And so as a result, there are probably more people living in rural parts of the earth than we gave them credit for. Researchers looked at a bunch of areas that were impacted by dams and changes to the local area and looked to see how many people were displaced. And they're like, oh, look at all those people. That's more than we thought. So there could be like 1 billion more people on the planet, maybe, than we thought.
But they're all living in flood zones?
They're all small farms. we can't get rid of the small farms. Yeah. So there's lots of great science out there, everybody. And there is also a lot of stuff happening that is really impacting the future of science in the United States. I really, really am going to continue to put forward that for all of us who appreciate science, if we can help and write letters to our congresspeople, to our politicians, if we can find ways to help fund science, if we can find ways to support science and education, If we believe in science and education as important to our society, as essential to our society, then we need to figure out how to be a part of supporting their continuance, because things are getting blown up right now. Everybody, go to sleep. Or if you're in Europe, get up. Go do something.
Dr. Kiki's hypnosis show. And now, sleep.
That's right. I've been working on you all night. There we go. All right, everyone. Thank you so much for joining us tonight for this episode of This Week in Science. Thank you to all of you who were in the chat rooms tonight, talking about all the stories with us and talking with each other. Thank you, Aaron Lord Gord, Paul Disney, others who help keep the chat rooms really great places to hang out. Thanks for being there and making sure that we can all keep talking to each other openly. Additionally, thank you, Fada, for your help with show notes and social media. These are essential to how the show goes forward. Identity 4, thank you for recording the show. Rachel, thank you for editing the show. And of course, thank you to our Patreon sponsors. Patreon sponsors include Robert W. Farley, Lauren Gifford, Dana Lewis, Eden Mundell, Alan Viola, Aaron Anathema, Arthur Kepler, Craig Potts, Mary Gertz, Teresa Smith, Richard Badge, Bob Coles, Kent Northcote, George Corris, Pierre Velazarb, John Ratnaswamy, Chris Wozniak, Vegard Shefstad, Donathan Stiles, a.k.a. Don Stylo, Ali Coffin, Shubru, Sarah Forfar, Don Mundis, P.I.G., Stephen Alberon, Daryl Myshak, Andrew Swanson, Fredos 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard Brendan Minish, Johnny Gridley, jeez, Remy Day, G. Burton Lattimore, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, Lon Makes, EO, Adam Mishkan, you too, Mr. Kevin Parachan, Aaron Luthen, Bob Calder, Marjorie, Paul D. Disney, Patrick Pecoraro, and Tony Steele. I'm calling out a couple of people because I know they are having a wonderful time right now. I wish I were there too. Anyway, these Patreon sponsors, this list of people, they are central to the show that we do and keeping the show going. If you would like me to try to read your name and pronounce it correctly, quickly in this list at the end of the show, please head over to twist.org and become a supporter. Click on Patreon, the Patreon link, and head over to patreon.com to support TWIS. On next week's show,
we will be back 8 p.m. Pacific Time, 5 a.m. Thursday Central European Time on our Twitch, YouTube, Facebook, and other streamy channels.
Dreamy channels.
If by chance you want to
you want to keep going, you go.
As a podcast, just search for This Week in Science wherever podcasts are found. And if it doesn't come up, it's because your algorithm is too narrow-minded.
Yep,
if you enjoy it, because you enjoyed the show, get your friends to subscribe as well. For more information on anything you've heard here today, show notes and links to the stories are going to be available on our website, www.twist.org, where you can also be sure to sign up for a newsletter, but never have to put up with getting it. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes due in the night, please let us know on one of our social media accounts, or email accounts, or just put it in an envelope.
Carrier pigeon.
Fold it up, put it into a bottle along with the carrier pigeon, put a cork in it, throw it into the ocean, and eventually we'll hear it.
We will, but make sure you put TWIS in the subject line so your email doesn't get...
Will not...
Do you have one?
Will not be mined from the bottom of the ocean like so many nodules and turned into an electric car that would be set on fire for the insurance money.
Oh, no. Don't do that.
That's what would happen to it if you don't put TWIS somewhere in the subject line. We look forward to talking about science each week with you. If you learned anything from this show, remember,
It's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.